Okay, so we're gonna talk about the overview of the recovering boiler process and the equipment that being used in this process. So if we're gonna talk about the overview, we must to know what is a recovery boiler. A recovery boiler is a key component of the craft process, which is used to make paper pulp from wood. A recovery boiler accomplishes three major tasks, such as burning the black liquor, recovering the inorganic chemical for reuse, and generating superheated steam. So, in recovery boiler consists of water-walled furnace, where the combustion of the black liquor is complete followed by a series of heat traps, where the hot combustion gases are cooled and superheated steam is generated. There are three key parameters that are considering in designing a recovery boiler. First, heat input per plant area. Second, furnace volume per heat input. Third, flue gas temperature leaving the furnace. Okay, we already talked about the overview of the recovery boiler process. Now we're gonna talk in generally equipment that being used in a recovery boiler. There are such as the furnace, black liquor nozzles, air nozzles, superheater, economizer, evaporator, dissolve tank, causticizing plant, and last, there is the stack. Next, we're gonna talk about the more detail of the equipment that being used, that being told by my friend, Apriyani.
1. Black liquor mix tank. Concentrate black liquor is pumped with black liquor transfer pumps from evaporator to black liquor mixing tank. Usually there is two pumps for the action. In black liquor mixing tank, concentrate liquor is mixed with ash from recovery boiler hoppers and electrostatic precipitators. Mixed ash contains mainly sodium sulfate Na2SO4 and sodium carbonate Na2CO3. After mixing process, concentrate black liquor is called black liquor ash fired. From mixing tank, black liquor is pumped with spray guns pumps to black liquor preheaters. Preheating will heat the black liquor up to 100 to 130 degrees Celsius degrees. Temperature of black liquor is affecting to viscosity of liquor. Viscosity instead is the key element when spraying black liquor droplets to furnace and burn black liquor. Black liquor temperature is very important. After preheating, black liquor is entered to liquor guns. From liquor guns, black liquor is sprayed to the furnace and burning process starts in furnace. For recycling purpose, there is also backflow line from liquor guns, which usually leads to black liquor mixing tank. See Figure 12 black liquor system.
Next up, we're gonna talk about the furnace. The furnace is where the recovery boiler burning process happening. The main burning material for the furnace is the black liquor, but in startup or shutdown situation, oil or gas are used as a support of liquor burning. Also, there can be load burners in the recovery boiler to increase the boiler steam capacity. Furnace burning process can be divided into two zones, reduction and oxidation. You can see the recovery boiler, furnace oxidation, and reduction zones in Figure 15. Reduction area is below the liquor guns and oxidation area is above. The fuel, which is black liquor, is fed to the reduction zone where the liquor droplets will drain and partly gasify on the way to the bottom char bed. Droplet size from the black liquor nozzle must be large enough to land in the char bed, but not too large so it won't land too early without draining properly. Too small droplet size can be entrained among the fuel gases and form carryover in the upper parts of the boiler. Regeneration of the black liquor in organic chemicals and burning of the organic wood compounds demands different kind of circumstances. Chemicals are regenerated in the bottom of the furnace with the help of primary air. Primary air helps to keep the char bed in shape, and the temperature is approximately 1000 to 1100 degrees Celsius. The amount of primary air is 30% to 40% from the total air amount. There is also secondary air, which purpose is to burn the gasified components from the char. The amount of secondary air is typically 50% to 60% from the total air amount. Organic materials are burning on top of the char, and inorganic materials, also called smelt, flows away from the furnace along the smelt spouts into the dissolving tank below the boiler. Recovery boiler reduction rate can be up to 98 to 99% if process conditions are right. Oxidation zone aim is to complete the burning from reduction zone with the help of tertiary air. In oxidation zone, tertiary air and the burning gas must mix perfectly to ensure the end of burning process. To get this burning, the air speed must move fast enough, around 65 to 80 meter per second, and the air pressure must be large enough, around 2000 to 3000 pascal. Also, the burning air openings must be in the right position. The amount of tertiary air is usually 10% of the total air amount.
Superheater recovery boiler reduction rate can be almost 100% or 98 until 99% if process conditions are right. Oxidation zone aim is to complete the burning from reduction zone with the help of tertiary air. In oxidation zone, tertiary air and burning gases must mix perfectly to ensure the end of burning process. To get this burning air speed must move fast enough, or 65 until 80 meter per second, and air pressure must be large enough, or 2000 until 300 PA. Also, burning air opening must be in right position. Tertiary air amount is usually 10% of total air amount.
Boiler tank. The function of the boiler tank in a recovery boiler are to store the black liquor, to provide a resident time for the black liquor to burn, to recover chemicals from the black liquor, and to generate steam and heat. The boiler tank is a large, cylindrical vessel that is lined with refractory material. The black liquor is pumped into the boiler tank and is sprayed into the burners. The burners ignite the black liquor, and it burns to produce steam and heat. The steam and heat are used to generate electricity or to power other mill operation. The chemicals in the black liquor are also recovered in the boiler tank. The chemicals are volatilized during the combustion process and are condensed in the recovery boilers. The condensed chemicals are collected and are used to make new pulp. The recovery boiler
is an important piece of equipment in the kraft pulping process. It is used to recover chemicals and energy from the black liquor, which is a byproduct of the pulping process. The recovery of chemicals and energy is an important part of the kraft pulping process because it reduces the amount of chemicals and energy that need to be purchased.
5. Economizer. Earlier, the recovery boilers had horizontal tube economizers. They plugged fast and had to be weather washed at intervals of 1 to 4 weeks. It was not until the early 1960 that installing vertical economizers started. In economizers of vertical flow design, the gas flows downwards and weather counter certainly upwards. In a period of few years, the current long flow economizer design emerged. Figure 1 to 14. Vertical economizer design spread fast in Scandinavia, where by mid-1970s, more than half of the recovery boilers had long flow economizers without direct contact evaporator. In competition to purely vertical, the three-pass design featured gas flow which was forged crosswise the economizer tubes to improve heat transfer. There have been several rounds of economizer heater designs. In a typical old design, each economizer tube is connected to a common larger header. As maximum number of tube rows that fit to this type heater is about 8 to 10. The larger economizers must have front and back headers. This design has the disadvantage of having a header in the gas flow. The header can correct and the welded joints then to relieve thermal stress. Modern economizers have flat horizontal headers. Economizer is a tubular heat transfer device used to heating the boiler feed water before entering the steam drum. The term economizer is taken from the usefulness of the tool, which is to save to economize the use of fuel by taking the heat recovery of flue gas before it is discharged into the atmosphere. Take the heat recovery of flue gas before it is discharged into the atmosphere. The Bureau of Energy Efficiency 2004 states that an economizer be used to utilize flue gas heat for preheating boiler feed water. Every 220 degrees Celsius flue gas temperature through an economizer or preheater, there is 1% fuel saving in the boiler. In the boiler, every 600 degrees Celsius increase in feed water temperature through the economizer or a 200 degrees Celsius of combustion air through the air preheater. There is 1% fuel saving in the boiler. The performance of the economizer is determined by a fluid that has a low heat transfer coefficient is a gas. The heat transfer rate can be increased by increasing the total heat transfer coefficient by arranging the arrangement of the tubing or fin properties and increasing the heat transfer contact area. The response generated by the economizer are heat transfer effectiveness and operating costs. Heat transfer effectiveness is the amount of energy that can be extracted from the total amount of energy that can be absorbed energy that can be absorbed. The greater the heat transfer efficiency in the economizer, the more residual gas heat will be taken. The greater the heat transfer effectiveness, that occurs, the more efficient the device is.
Electrostatic precipitator. The electrostatic precipitator is used to remove dust from the flue gas leaving the recovery boiler. It is located at the end of the train just ahead of the stack. The dust that is removed at the precipitator is primarily sodium sulfate or salt cake, and it is recycled to the black liquor and refired into the recovery furnace. Precipitator dust also tends to be enriched in chloride and potassium. If the mill has plugging problems due to chloride accumulation in the recovery cycle, some of the precipitator dust may be dumped in order to purge chloride. Some chloride removal processes also start with precipitator dust. The precipitator efficiency determines the dust load and stack opacity. This effective precipitator operation is critical to meeting the environmental restraints on the recovery boiler.